Hey there guys, my name is Michael Perez. I'm from Los Angeles, California. I'm currently in Costa Rica. I thought I would take a few minutes to consolidate a few thoughts. So often when I'm coding really late at night at a coffee shop, people tend to approach me and ask me questions like, hey, I always want to become a programmer, where do I start? Or this looks really tough, why do you do it? How do you do it? And I thought I'd answer some of these questions, especially for people who are looking to enter the industry. This advice might be pretty helpful. One of the most valuable things you learn from computer science is not how to code, it's how to think. Thinking like a programmer doesn't just change the way you work or your professional career, it completely revolutionizes the way you think as a scientist. When trying to solve real-world problems, nature is probably the best place to look for inspiration. Take a bird, for example. A bird can achieve the amazing feat of flight. However, its wings, which it uses to fly, are not particularly the best tools for flight. I would argue that biological systems don't need to be ideal at all. They merely need to meet the minimum requirements dictated by natural selection. Evolution didn't choose the materials needed to build that wing. Rather, it was forced via successive mutations and variations of genes to manipulate that limb and transform it into a wing. So, an engineer would study this bird, understand its mechanics, how it flies, and then rebuild it with ideal materials. And it's a thought process like this that allows us to take airplanes around the world, travel to the moon, and send rovers to Mars. I challenge you to look at any modern invention. It's all inspired from nature. It's all inspired from our surroundings. And this is no different for computer science. Computer science is heavily reliant on abstraction. And if you'd like to read up more, you can read up on polymorphism, encapsulation, and inheritance. These are real powerful mechanisms that run object-oriented programming. Learning how to code and think in an abstract fashion provides one with a valuable lens in which they can see science and life with a much greater degree of depth. Another valuable asset developed through the practice of computer science is a heightened sense of articulation. Computer science and object-oriented programming requires you to articulate in great precision anything you choose to create or develop. Of course, being articulate is important in a general sense, but its ramifications with respect to science are a lot greater than that. For example, and bear with me, this is the reason why we look into the vastness of space. This is why we study black holes, so that we can better understand the laws of physics and help improve life here on Earth. Differentiation of any system is best defined at its extreme conditions. For example, when I'm asleep, I am no different than another human being when they're asleep. However, when I'm awake, or when I'm angry, or when I'm sad, when my emotions are heightened, the differences between me and someone else become very obvious. With respect to computer science, this valuable form of articulation becomes well exercised. For example, that last iteration of your loop that you forgot to consider is crashing your code, or you did not realize that this array you're iterating through is zero-based counting, not one-based counting. It's that one last quirk of logic in your code you forgot to consider that creates a vulnerability and the opportunity for a hacker to break into your system. Articulation is key in computer science, and gaining experience as a programmer affects your ability to articulate way beyond the scope of computer science. So one of the most important qualities to being a good programmer is patience. Whether it be at the architectural stage, or whether it be at the development stage, or whether even at the debugging stage, patience is key. When you're in the debugging phase, sometimes it can take you days and days and days to find a silly or frivolous little issue in your code. And that's common, and you have to expect that as part of the life cycle of your program. And of course, as you get more experienced, you tend to know how to avoid these kind of conflicts, but during your initial stages, it can definitely be a very complicated process. Computer science, or even low-level science in general, has that issue where it's complicated at first, but once you train yourself to think in this way, I promise you, it's really not hard at all. Even when you are far along the journey of your academic pursuits, with computer science specifically, it's really hard to see the application of what you're studying till the very, very end. So this is where patience and confidence plays a strong role. You must dig into the trenches of whatever it is you're studying at the time and really hone those critical thinking skills, because those are the important skills you'll take with you post-graduation. Of course, especially if you are unsure which field of sciences you should take at college. Computer science will prove useful to whatever path you decide to take. For those not taking the college route, the world is at your fingertips. I mean, the internet is one of the best sources to learn how to code. I can put some links below in the description on great places to start. Someone named Bucky, or the New Boston, posts amazing videos, step by step, teaching you an array of languages, whether it be PHP, Java, Python, C++. It's all there. Now, on to my advice for those studying computer science. I believe the key to success in any of these fields, whether it be mathematics, computer science, any logical sciences, is to understand the material, not memorize it. At first, memorizing can work, but if you develop that ethic, you'll have a very hard time in the long run. Now, the common question, which language should I start learning? And that really depends on your philosophy of what you're trying to achieve. For those trying to get into the industry really fast, I would highly recommend web development. The money's really quick, it's fast, and it's easy to get on board. If you really want to delve into the complexities of programming, I highly recommend you learn something that's strictly typed, object-oriented, something like Java, C++, or C#. Those will really get you thinking, and those will really master your skills as a programmer. As for those who are unsure whether they should study computer science or mathematics, as someone who's majored in both, I would tend towards mathematics. Mathematics can be extremely theoretical, so you really want to graduate with some direction forward. Sometimes people who do graduate in mathematics have all these unique ways of thinking, but really not much to apply to. So I think computer science is a great minor to take as well. Be patient, guys, and don't be afraid of complexity. For those who have any questions, feel free to ask them below. Have a great day.